رح نبلش مع متحدثتنا الأولى الدكتورة نانسي العساف. دكتورة نانسي عساف she is assistant professor in University of Jordan. هي حاصلة على درجة الدكتوراه من جامعة تكساس A&M 2019 وهي متخصصة في مجال البيم. من مجالاتها البحثية اللي عم تشتغل فيها computational design, digital fabrication techniques, BIM, parametric modeling, design optimization, AI-driven architectural design, logic-based approaches. فدكتورتنا العزيزة نانسي.
بداية كل الشكر لكم، وأنا سعيدة جداً على تواجدي معكم اليوم، وحابة أحكي اليوم عن AI و how it would disrupt actually architectural education. Okay. So in this presentation, basically we'll talk about AI revolution. And then about assessing our readiness for AI. Are we prepared for AI-enhanced architectural pedagogy? And then charting the course, a strategic roadmap for AI integration in the architectural curriculum. And then an implementation roadmap with a discussion of the policies and implementation strategies that we should have in order to implement AI. First, for the AI revolution, let's start by understanding our context. Today, around $20 billion are actually dedicated for AI education market. Around 85 million jobs were replaced by AI, and 97 million new jobs were actually created by AI. Moving to architecture, in a recent survey by RIBA, around 73% of architects actually believe that AI benefits the architectural design process. 69% of the architects believe that AI are actually, or they actually implement AI in their design firms. 49% they think that AI helped them to overcome design complexity, and 46% of the architects believe that AI helped them to achieve more sustainable solutions. Also, 43% of the architects believe that AI helped them to have more efficient design. Unfortunately, or actually on the other side, 36% of the architects believe that AI is actually a threat to the profession. Moving to education, AI can actually automate 40% of the load of the teachers. Actually, also AI can provide support to students with 91% accuracy. Therefore, AI actually reshapes architecture and education frontiers. Embracing its transformative power in architectural education is not an option today. It's a necessity to shape the architects of tomorrow. Moving to assessing our readiness. Are we prepared for AI-enhanced architectural pedagogy? Actually, we face several challenges. We can outline those challenges as following. First, we have a challenge in the infrastructure and resource constraints, such as budget limitation, outdated technological infrastructure, and limited access to cutting-edge AI software. We also have outdated curriculum, and basically, we have a disconnect between what is taught and the skills that are required for AI integration. We have a problem and a skill gap, such as the lack of computational literacy among students and faculty, unfamiliarity with AI tools and data analysis techniques, and insufficient of data literacy skills. We also have the problem of ethical and social considerations, such as the lack of policies and AI ethics, and issues related to data privacy, algorithmic bias, and responsible use of AI. Today, we are at the age of post-digital. That means the question whether we should teach or use digital design tool is not a question anymore. Everything is digital. The question is actually how we can teach those tools and implement them with the core principles of architecture. Therefore, artificial intelligence is the science of making machines do things that would require intelligence if done by humans. So the question, can our students judge the outcome of AI tools? Can we prepare our students for AI-enhanced learning? I'm proposing a multidimensional skill matrix to prepare our students for this, starting with knowledge domain, focusing on architectural principles and fundamental knowledge, moving to the digital skills such as computer-aided design tool, building information modeling, which is a core, visual programming, language, and scripting, then moving into data literacy, such as data collection, processing, analysis, and data literacy with computer science, then focusing on the critical thinking and problem solving, such as analyze, evaluate, and formulate creative solutions, then the culture of adaptability and lifelong learning, and finally, we end with system thinking. System thinking as analyzing complex systems, evaluating the relationship between the components, and creating holistic solutions. I'm going to share two experiments or two examples from the University of Jordan. The first studio for the first year students actually focusing on analog computing for rule-based design. It adopts a system thinking pedagogy in which a student would adopt rule-based design, reasoning, and algorithmic thinking in order to transform a cube by implementing 3 integrated systems and using explicit sets of design rules, such as rules for splitting and shifting and scaling and replacing or substitution rules. Same students took this exercise further, and they used diffusion model in order to transform their abstract models into architectural expressions, as we can see here, and you can take a better look at the project at the exhibition downstairs. The second experiment from third year studio, which is a BIM pattern-based pedagogy. In this studio, we adopt actually a computational design formal language in which a student, they have to analyze existing formal language and mapping it into parametric system in BIM to develop parametric conceptual diagrams that can be used to create consistent expressions following the same formal language. The student also used an AI tool, which is Enscape, integrated with BIM in order to design the space from the scale of human and understand the quality of space. They also used diffusion model tools, especially with technique of text-to-image and image-to-image to understand the quality of a space if it's designed within the language of a specific architect. Also, we used Autodesk Forma, which is a performance simulation tool that can be used at the early stage, at the early design stages in order to understand the performance of the building at its early stages. Now we move to charting the course, a strategic roadmap for integrating the AI in architectural curriculum. This can be understood according to 6 main modules. The first module is actually about AI theory and ethics module. This module focuses on integrating AI into theory and research courses for data-driven analysis and addressing ethical consideration. Courses that can implement this module related to contemporary architecture, history of modern architecture, theory of digital design, and the new courses such as AI in architectural education. The second module where we can implement AI is the technical module, which focuses on data processing, parametric modeling, and coding skills. In courses such as parametric modeling, programming for architects, and advanced parametric modeling courses. Then we can also implement AI in the third module, which is AI presentation module, focusing on VR, AR with AI-driven rendering, which would help students to identify flows and opportunities in the early design stages. The fourth module is the AI performance module, in which students can actually implement AI tools in order to conduct performance analysis at the early design stages, such as for the energy modeling, daylight tools, structural integrity. Those can be in courses such as energy simulation and advanced parametric modeling. We have 2 examples here. The first one is Autodesk Forma, which the students in our third design studio actually use. The second example is Cove, the tool developed by Arab company, which would give us a profile of the building performance at the early design stages. Then the fifth module is AI construction module, in which AI can be implemented also in courses related to construction, for coordination or clash detection, and we can use various machine learning techniques. This can be integrated in courses such as building information modeling, digital fabrication, and contract specifications and quantities. And an interesting example is actually OpenSpace.ai, which would take the BIM model and compare it to reality and give us feedback about the relationship between the reality and the proposed model. And the last and most important module is actually the design studio, which would integrate all the five models within this module. We can start integrating AI starting from third year design studio, in which a student would learn how to explore generative design iteration, text and theory development, conceptual design development, visualization, and even simulation within the design studio. This interesting example from Hyper, an AI tool that can be used to develop the architectural program and spatial relationship in the early design stages. Finally, an implementation roadmap, recommendation policies, and implementation strategies to implement AI in architectural education. Any strategy to implement AI in architectural education should actually be a human-centered AI policy. This have 4 dimensions. The first dimension is the governance dimension, which focus on established data governance. That means policies for privacy, transparency, accountability, and security. Then we have the resource allocation, ethical guidelines, and ensuring equity in access to AI. The second dimension is actually industry collaborative projects. The industry is an integral part of this policy, in which we have partnerships with the industry, interdisciplinary collaboration, and industry feedback. The third dimension, which is related to operational dimension, by providing technical support and training in AI literacy, monitor and evaluate the AI application. And finally, the most important dimension is the pedagogical dimension, in which we have to rethink our assessment methods for our students, develop students' holistic competencies, encourage a balanced approach to AI, curriculum development, and foster a culture of continuous learning. Finally, the future is data-driven, integrated, and collaborative. And architectural education must adapt and focus on empowering students and creatively. Thank you.